Good morning. My name is Stephen Richardville. This is assignment 4.1 for Advanced Statistics, Fall 2023, where we will be performing a correlation test from the statewide school district data. In particular, based on this assignment, we'll be performing a correlation between or test between the students on free and reduced lunch and those scoring at the exceeding level in math for our school district data that we've been using all semester. So if I go to my data, we're going to be talking today about the Pearson R correlation test, which can also be used with the Spearman-Rowe, depending on the test for normality, linearity, and homoscedasticity. If I go first off to double check, although we are, again, assuming that we've met all the conditions for the Pearson R or the Spearman-Rowe test, just to double check, we're going to go quickly to analyze here. Descriptive statistics, I want to show you how I would go through this. We're going to compare specifically the variables of free and reduced lunch and exceeding in math. And we're going to go to charts. We're going to click on histogram. We do want to show the normal curve there. All looks good. We do not need to display the frequency tables. We just want to look at the curvature, the normality curve. And when we pull up our histogram, you can see for free and reduced lunch versus frequency, our test of normality looks pretty good, as does for the students excelling in math. Our frequency looks pretty good, pretty normal curve there. Next, we need to check linearity. So if I go to graph, chart builder, and ideally here, when I go to scatter or dot plot, I have the dot plot with a linear regression. Now my gallery on this version 29 doesn't have that graph, but we're still going to talk about it and how we would apply it in this regard. What I'm going to do is I'm going to bring over free and reduced lunch for my Y variable. It could be X. It actually doesn't matter in this case. We're looking for linearity, which won't matter which variable is on which axis. Although all math exceed is my other math exceed here. Let's go ahead and pull down math exceed. Okay. So those are my two. All looks good here. I'm going to click OK. And we're going to look at the scatter plot. And there's a couple things we can notice with the scatter plot. One, it seems to be a negative relationship. We'll talk about that in a minute. Also, if I were to look at a linear regression through the middle here, the test for linearity looks like it's been accounted for or met. There's a pretty good linear regression right through the middle here. And also the homoscedasticity. That's the fact that it kind of bows. If I were to draw an oval around this, it kind of bows a little bit more here in the middle and a little bit tighter here on the end. So I've got a pretty good negative linear relationship. And I've also got the homoscedasticity, meaning for the most part here, the ends are a bit tighter and the middle is where the bit of the bulge comes from. I can draw a nice oval around here. So all three conditions are met for the Pearson R test. Normality with the histograms, and then with these bar charts, I can see the linearity and the homoscedasticity. So now I'm ready to go ahead and do the test. What we're going to do is we're going to go to analyze. In fact, I can kind of close this. I don't need this anymore. I'm going to go to analyze, down to correlation, and we're going to look at bivariate. With bivariate, once again, well, I've already done it, but let me go ahead and reset it here just so we can see. I'm going to do free and reduced lunch, and I'm going to do math exceed. Everything looks okay over here. And Pearson R, two-tailed, and flag significance. So those are my three key here. If I was doing the Spearman-Rowe test, I would be checking over here, but I did meet the conditions of the Pearson R. So I'm going to go ahead and do that today. Two-tailed, and we want those significant correlations. And I think I'm ready to check my correlation. Okay, so what do we have here? The negative means that it's a negative relationship, meaning that as my free and reduced lunch percentage increases, the math scores actually do not increase, they decrease. That's that negative relationship. Or as the free and reduced lunch percentages go down, the math scores actually go up, those exceeding in math. And the fact that it's 0.696 with -1 being the highest negative correlation, 0.696 is a pretty strong negative correlation. Also, it is significant because of the two-tailed test shows me I have a number of much less than 0.05. So it is a very significant difference, and it is a negative strong correlation. Whereas again, 0 would be no correlation, Positive one would be a positive strong correlation. Negative one would be a strong, extremely strong negative, in fact, the most strong. So a negative 0.696 means has a negative correlation and a fairly strong one. So there's your correlation test using Pearson R of the percentage of students on free and reduced lunch versus those with exceeding math scores. Thank you. Have a great week.